As you were learning C, you discovered pointers and pointers on functions. These are very useful tools if you use them often, and I believe you've had a hard time at the beginning, as we all know pointers are tricky. Of course, both pointers and pointers on functions still exist in C++, but they come with two new friends, namely pointers on members and pointer on member functions. So today, we're going to find out how to use them, and more particularly, what they're used for. For that, I'm still using our good old ordinary sample class that will contain a foo integer and a bar bracket member function. Nothing extraordinary. In the implementation, we can see that it's exactly the same thing. There is absolutely nothing interesting about it. This class is just mundane. Our foo member is used by an initialization list here and set to the value 0, just to have an initial value. We then call the constructor, the destructor, and our bar bracket member function. We always have a message telling us where we are. This part isn't interesting. What is interesting is what is going to happen in the main bracket. As you can see, there's a lot of code and a few scary lines. We'll walk through them to understand everything. Let's start with something simple. Remember, we're able to declare variables that will be allocated on the stack. That's the case here. Here we have a very simple instance of sample on the stack. I could also declare a pointer still on the stack and assign it another variable's address as a value. So in this line, we have a basic pointer just like in C. It's a pointer on a particular type, sample, and I assign it an address. It's an assignment here, but it could have been an initialization, the address of my instance variable. My pointer is instance sep, my instance, my variable. I'm taking the address, nothing new. It's a pointer. Let's take a breath and move on to the next part. This here is the syntax of a pointer on member attribute of my sample class. It's a pointer that will allow me to take an address of a member attribute of my sample class. The example I wrote contains a foo member attribute, so we'll see later in the code that I can get the address of this foo member attribute. Let's see together the syntax and details. It's just the syntax of a normal pointer if you remove this part. We still have the type pointed to, the type we take the address of. The star character, allowing to tell that it is an address type. The address of an integer, and the name of my p pointer here, which I will initialize to null here. Why not? By adding sample : before star, I'm no longer declaring a simple pointer, but a pointer on an integer member of the sample class. For now, ignore this line. I'll get back to it in a moment. So here, I just have pointer on an integer member of the sample class initialized to null. Below that, I'll be able to assign the address of my foo member to a pointer. We have the exact same address as with simple pointers. It means that here I have my pointer, and I put the address on a variable. More particularly, my instance variable of sample type. Instance sep is of sample address type, so I'm taking the address of variable of sample type. This line is identical. P is a pointer taking the address of an integer member of the sample class. I'm taking the address of a foo member of the sample class. To make sure of this, we have right below an example lines allowing to demonstrate all of this. In particular, I'm starting with an initial output of my foo attribute at t = 0. Then I can assign a new value to my foo using the pointer. For that, I'm introducing a new operator that you don't know yet. It's the .* operator. Instance star p will allow to assign the value 21 to p. What exactly does dot star operator mean? Let me think for a moment. I told you I was taking the address of a member, foo here, of my sample class. But which one? Because my foo attribute may exist in every possible instance, here I declared an instance of my sample class. I could have many of them, so the question is, which one is my foo attribute? On this line, when I get the address, it's something not specified yet. And to find out which instance I'm referring to when I want to use my foo attribute, I must specify the instance in question and use the special operator dot star on it, allowing me to use my p pointer with this instance in particular. This line means that I will assign the value 21 to the content of the p pointer of the instance. Nothing complicated so far. Now, as we're talking about pointers, I may either use directly a stack instance or a pointer. So I'll have a dot star operator for the stack instances and the negative greater than star operator for pointers. In summary, here I'm using directly my instance, on which I want to update the foo member with my p pointer to the value 21. To do that, I'm using the dot star operator. In the case where I'm not using directly an instance, but a pointer on instance, I'm no longer using the dot star operator, but the negative greater than star operator instead. We can see the syntax is the same. Please note that it's actually the pointer I used, instasep. It's this variable indeed. Okay? Now we'll do the same thing. We know how to point on a member attribute. This time we will use this to tackle the problematic of pointers on member functions. The principle is exactly the same and is directly inspired by the syntax of pointers on functions that we used to have in C. Remember, in C, we'd write something like void star f void. Here in C++, I want to point on a member function of a class. I will just reuse the same syntax, but this time I will specify which class I'm referring to. Exactly the same way I would with pointer on member attributes. So I'm using sample : with the name of my pointer, and then I must make the assignment. Note here that in my class, I declared and defined the function bar brackets as const. And I want to have a pointer on a const member function, so here I added in the signature of pointer on member function. Then I'm pointing on a const member function. It's very important. All this defines the type and the name is here. It's a little bit complicated, but if you check the syntax of pointers on functions and understood the syntax of pointers on member attributes, it's actually very simple. Now let's focus on this line. I'm just going to say that my f pointer will now point on bar brackets member function of my sample class. But in the same way as a member attribute, I can't tell which instance I'm referring to. For member functions, I don't know either which instance of my sample class I'm referring to. So I'm going to use again the dot star and the negative greater than star operators to specify which instance I'm using my pointer on member function with. Here, I'm using directly an instance variable declared here. So if I'm using the dot star as it's not a pointer to call my f pointer on function that has been assigned here. If I want to use a pointer, in particular instasep declared here, I'll be able to use the negative greater than star operator to use my pointer on member function. So we'll be able to compile and run all of this to make sure we're good. Let's run it. I can see that the member foo of my instance was indeed initialized to 0. Then, thanks to my pointer on member, I've been able to change the value of my foo member from 0 to 21. Then change it again from 21 to 42. Here I'm setting it to 21 using an instance directly, and 42 using the pointer on my instances. Similarly, I was able to the bar bracket function, this time using the instance of my class, and this time around using the pointer on instance of my class. I understand it's complicated because here we have two conflicting levels of pointers. Do I have an instance or a pointer on instance? And then, do I have a pointer on a member or a member function? Take some time to view the video a second time. Read the code carefully. Read some documentation on the net, and you'll realize that it's not that much complicated. It's basically a simple pointer and a simple pointer on function, with a little extra syntax to introduce the notion of class. Just as pointers on functions in C were extremely practical, to write dynamic and efficient code, you probably remember this array of pointers on functions that you were using every time you had to write a dispatcher or anything along those lines. Remember, for instance, your printf project. There's no reason you wouldn't have the same problematic in C++. And when you have a collection of instances, a collection of instance member functions, you'll be able to use pointers on member functions to select the right process. That's it. I'll let you meditate on this last video a little more complicated than the others. And I'll see you in a moment for the conclusion for this day.